Welcome to Sticky Med, learning medicine, stick by stick.
So, right now, as you're listening, your body has two jobs. First, the bladder has to be a relaxed, expanding reservoir.
And second, the whole system has to be sealed completely shut.
Perfectly put. As the bladder starts to fill, its walls stretch, and there are stretch receptors in the main bladder muscle, the detrusor muscle. They send these initial signals down to the spinal cord. We're talking about the sacral segments, S2 through S4. This immediately kicks on the sympathetic nervous system.
And that's through the hypogastric nerve.
Yes, through the hypogastric nerve.
Wait, hang on. I have to stop you there because that just seems backward to me. Sympathetic activity is fight or flight. It's about action, getting your heart rate up. Why is this system that tells you to run from a bear helping your bladder relax?
That is a fantastic question, and it's a key insight. The effect of the sympathetic nervous system depends entirely on where the signal lands.
On the receptor.
On the specific receptor it interacts with. In this case, when the sympathetic signals hit the detrusor muscle, they're looking for one thing: beta-3/3 adrenergic receptors.
Now, the beta-3 receptor is the secret here.
It's the specific molecular instruction. Activating that beta-3/3 receptor tells the detrusor muscle, relax, stay quiet. And that's crucial. It lets the bladder fill up with a lot more urine without the pressure going through the roof. It gives it compliance. It's like having a very stretchy storage tank.
Okay, so the sympathetic hypogastric nerve is keeping the tank relaxed through those beta-3/3 receptors. But what about the seal? We need to lock the door.
Exactly. And the sympathetic system handles the first involuntary lock. That same hypogastric nerve also causes the contraction of the internal urethral sphincter.
And that's the first ring of muscle right at the neck of the bladder.
Yes, and it's smooth muscle. It's completely involuntary.
And the receptor for that one?
Yeah.
It can't be the same.
It's not. For this job, it uses alpha-1 adrenergic receptors.
Yeah.
So you see this beautiful dual action.
One system, one nerve.
But two different receptors to get two jobs done. Beta-3/3 for relaxation of the main bladder wall, and alpha-1 for contraction of the internal seal.
That is brilliant. There's still that conscious part, the part that lets you wait in a long line. That can't be involuntary.
No, absolutely not. That's where the somatic nervous system, our voluntary command center, comes in. The third critical piece of storage.
And that would be the pudendal nerve.
The pudendal nerve. Think of it as the ultimate emergency brake.
Okay.
It controls the external urethral sphincter, which is skeletal muscle, like your bicep, the kind you can consciously flex.
So it's always on.
It maintains a tonic, a constant contraction of that external sphincter. That's your primary way of staying continent. It lets you actively override everything else and just hold it.
So storage is a three-part harmony. Sympathetic system relaxes the tank and seals the inner door, and the somatic system keeps the outer door locked.
A perfectly balanced system. But, that balance can't last forever. The bladder keeps filling.
Which brings us to section 2, the involuntary voiding reflex. So what's the trigger? When does the body say, okay, that's enough, time to flip the switch?
It's all about tension. The sources say that when the bladder gets to a critical volume, say around 300 to 400 milliliters.
Which isn't that much, really.
No. But the stretch receptors, which were just sending quiet signals before, suddenly start screaming. They send these high-volume distress signals.
That's like a red flashing alarm.
Yeah.
And these alarms, they don't just stay in the spinal cord, do they? They go higher up?
They go straight to the top, all the way up the spinal cord to the brainstem. And this is where we meet the star of the show, the primary switch, the Pontine Micturition Center, the PMC.
The PMC. In the pons, deep in the brainstem, how does this one little center manage such a huge system flip? It has to turn storage off and expulsion on at the exact same time.
That's its whole job.
Yeah.
Think of the PMC as the master traffic controller. It decides if the light is green for storage or green for voiding, but it's never green for both.
Okay.
So when it gets activated by those strong tension signals, it does two critical opposing things simultaneously.
All right, let's break that down. Action 1 must be turning off all the storage stuff.
Correct. The great deactivation. The PMC sends out powerful inhibitory signals. It just shuts down the sympathetic output. So goodbye, hypogastric nerve.
No more relaxing the tank, no more sealing the inner door.
Gone. And it also inhibits the somatic output, so that tonic contraction from the pudendal nerve, it cuts that off too. It basically takes its foot off the brake.
And action 2, at the very same instant, is hitting the gas.
It floors it. It activates the parasympathetic nervous system. That's our rest and digest system, or in this case, rest and expel.
And this is a complete change in command. The parasympathetic system takes over through Which nerve is it?
The pelvic nerve is now in charge. It floods the area with acetylcholine, which is the main parasympathetic neurotransmitter.
And that acetylcholine is looking for its own specific receptors on the bladder muscle.
It is. It's targeting muscarinic receptors on the detrusor.
And unlike the beta-3/3 receptors, which told the muscle to relax, I'm guessing the muscarinic receptors have the opposite instruction.
The complete opposite. They scream, squeeze! The bladder wall begins to contract powerfully and rhythmically. It's actively trying to push the urine out.
So the main tank is squeezing hard. But what about the seals? The doors have to open.
The internal sphincter opens automatically. Remember, the sympathetic system was the only thing holding it shut via those alpha-1 receptors.
And the PMC just turned that off.
Turn it off completely, so that seal loses its signal and just relaxes. It's a passive opening. The internal door is now wide open.
Okay, this is incredible. The system is now primed to go. The detrusor is contracting. The internal door is open. Which brings us to, well, the biggest question. The part about voluntary control.
Yes. If this whole powerful involuntary reflex gets switched on by the PMC every time the bladder is full, why don't we just, automatically urinate right then and there?
Where does choice fit into this? This is the aha moment. If the PMC is the switch, who controls the person flipping the switch?
And that final permission, the ultimate override, comes from the highest level of control we have, the cerebral cortex.
Our conscious brain.
Right. And here's the fascinating part. The cortex doesn't start the process. Its power lies in its ability to inhibit the process.
So the cortex is like an editor. The PMC is shouting, go, 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 and the cortex is just hitting the veto button over and over again until the time is right.
That's a perfect analogy. Even with a full bladder and an activated PMC, the cerebral cortex exerts this strong, conscious, inhibitory control over the PMC. It's the gatekeeper.
So the moment we finally decide to go, we're actually doing two things consciously.
Two final conscious steps.
Yeah.
Exactly. First, you make the decision, you grant permission. And what that really means is the cerebral cortex simply removes the inhibition it was placing on the PMC.
It just lets go.
It lets go. And the second that happens, the PMC is free to act. It flips the switch, shuts down storage, and fires up the parasympathetic system. The whole cascade begins.
But there's still one more lock, the one we put there on purpose.
That's step 2. You consciously relax the external urethral sphincter. That's the skeletal muscle controlled by the pudendal nerve. You send a deliberate signal to release that final lock.
The coordination is just phenomenal. The cortex gives permission by removing its veto. The PMC flips the switch from sympathetic to parasympathetic. The detrusor squeezes. The internal sphincter opens. And then we manually open the final door.
And the result is micturition, the combined action of a powerful contraction and 2 fully relaxed sphincters.
To really lock this in, let's do a quick recap. A review of the 3 central neural structures, the governing body of this whole process.
A great idea. Focusing on these 3 makes it all click.
Okay, first up, at the heart of the reflex, the Pontine Micturition Center, or PMC.
Location is the brainstem, specifically the pons. Its main job, it's the switch. It's the coordinator that manages that mandatory flip from storage to voiding.
Next, the lower level hub, the Sacral Micturition Center.
Right. That's in the spinal cord, S2 to S4. Its role is the reflex arc. It's the local hub where the sensory signals come in and the motor signals to the pelvic nerve go out. It's the direct line to the bladder muscle.
And finally, the CEO, the cerebral cortex.
Location, the forebrain. Its role, voluntary control and permission. It works by putting the brakes on the PMC or taking the brakes off. It gives you conscious agency over a very primitive reflex.
It's incredible to think about. This process we barely notice requires this high-stakes balance between 3 different parts of the nervous system and multiple brain centers.
It really is. And understanding this detailed map, knowing the roles of the hypogastric nerve, the pudendal, the pelvic, and especially those receptors, the alpha-1, beta-3/3, muscarinic, it isn't just academic.
Right, you mentioned the clinical side of this earlier. Why is knowing about, say, a beta-3/3 receptor so important for doctors?
Because that's the target. That's how modern pharmacology works. If a patient has an overactive bladder, their detrusor is contracting too much, what do?
You'd want to block the signal that's telling it to contract.
Precisely. You prescribe a drug that's a muscarinic receptor antagonist. It blocks the pelvic nerve signal. On the flip side, if someone has trouble with storage, you might want to help the bladder relax more. So you could use a drug that stimulates those beta-3/3 receptors. Every treatment decision is based on this exact neural choreography.
Absolutely essential knowledge. And to leave everyone with a final thought, building on that idea of conscious control. If the cerebral cortex controls urination by removing inhibition rather than by actively starting it.
Just letting an already activated process run its course.
Exactly. It's a subtle but profound difference. So what other fundamental, seemingly voluntary actions in your life are actually built on highly controlled inhibitions, just waiting for you to give them the green light?